So now in this video, we're going to look at a PNP bipolar junction transistor that we're going to wire as a current source. So, or we already got it wired, I should say. But in any case, it's a current source. We have a resistor there. We're going to set a voltage across the resistor using a PNP bipolar junction transistor. We got our load over here. This is what's going to set the current. The load's not going to affect the current, but of course, it's a red LED. Needs about 2 volts to conduct. So it's going to take away 2 volts from this part of the circuit. So we got 5 volts to work with. I'll talk about these other symbols coming up right there. Just pretend like they don't exist. You can either focus on positive 5 volts in relationship to ground, or with this circuit, you could have ground up here and the negative supply voltage down there. Either or with all of them. And so, in any case, we have the resistor here, 220 ohm. Although facing that way, it doesn't really look like 220. Looks like something wildly different. So, in any case, we'll put it back in there. And top pin right there is the emitter up there. And base collector, 2N3906. So, we do need this 10K resistor for this to work properly. I wasn't sure if you did or not. That's why I got this jumper down there. We'll look at that. But in case, the brightness of the LED depends on the voltage we set across that resistor. So we have that resistor coming from the 5 volts there, and whatever I set this trim pot to, so there you can see we got a very low voltage, so we have a low output, or low voltage across the 220 ohm resistor. Reason why the LED is brighter, because we got that high input there, the positive supply. So the lower we get the voltage, the brighter the LED is going to be. Hopefully that makes sense. And the less, or the more voltage, I should say, we put up here, because that's higher, the LED gets dimmer. So we're getting closer to that voltage. There's less voltage difference, less current flows. And now there should be none. So in any case, and kind of looking through the camera at a weird angle, so I lost my grip right there. Now, let's get to this jumper. So again, I just gonna kind of throw a bunch of random stuff here. Again, this is not a circuit that you would really use a lot. And I tried to insert that while I was looking through the camera, and completely failed. So I'm gonna try to do this all in one shot. See how well that fits in. But maybe I will have to edit things down. There we go. So it's lit up now, and sometimes when you don't have resistance at the output of the trim pot, you risk a short circuit. We do not in this case, but you always have to be very careful. But we expect the LED to turn off there, but we expect the LED to keep getting brighter when we get to the negative supply, but we just cut it off. So we can't do the short there. I'll show the power supply though. But we got, I believe this goes probably up to 13 milliamps, even though the power supply I've only seen say 12. But yeah, there we go, 12, and now did went to 13. Now it's 20. So actually, yeah, this is more current than I saw before. Maybe we didn't get CC up there though, so we did not short circuit it. But we're getting very close to our maximum current right there. So we do have some protection in this case, but generally speaking, don't put no resistance at the output if you might short circuit. That's very important to be aware of. So we will come to that. We do need it though to make sure we get a voltage across that resistor. So you can see we got the LED to the negative supply right there. If we go all the way to the positive, it doesn't matter. Current does not flow positive to negative that way because it's a PNP bipolar junction transistor. The current flows this way. That's how the current flows. So if we shorted this to ground, which you saw is when the LED shuts off, if we short it to ground. That's because we got this current path there. That resistor limits the current. So that's probably what gave us about 19 milliamps of current, approximately. We probably had about 5 volts, well, minus 0.6 volts right there, across the 220. So like 4.4 volts, I would say. And then headed straight to ground. We still got that resistance along that path there. That's why we don't need that resistor to protect the circuit from high current. But we do need this resistor because when we go to ground right there, that's a short. No, there's no reason for current to go this way. It's all going to go that way. That's why the red LED didn't light up. We didn't build up more than 2 volts there. When this is shorted to ground, current just goes right to ground, right there. So we got this resistor. It still helps, or it still does a good job transferring the voltage over there. Whatever we set with the trim pot should be at the base, but whatever's at the base will get over there. But if we go down here, there's that resistance there to let a little current flow, and then it flows, more easily down that way, right there. So, not going to go into great detail on that. Hopefully that makes sense, because at this moment especially, that's about all I can do to explain it. So yeah, there should not be a jumper here, but you don't have the high current dangers. Even though it's higher than what it would have been through the LED, it still wasn't dangerously high, because we had that 220 ohm resistor, and we're working with 5 volts. Also, you can see the trim pot's to the left over here, transistor to the right, and I have them swapped. Whenever you look at a schematic, if it helps, build it like you see on there, if you have the space or whatever. But to manage your space better, put the components however it manages better. So I decided, instead of because I have these orange jumpers, they go right there. The yellow jumpers, they kind of take up more space. It's harder for me to fit components if I put the trim pot in this side versus that side. So for this video, I decided to put it over there. I think in most of my previous videos, I put the trim pot over to the left and the other circuitry to the right. Doesn't work out as well, but it's probably a little more easy to understand in the video. I made this video before this circuit, so I'm probably, maybe I put the trim pot there, but I doubt it. But in any case, we're not going to dwell on that. You don't have to build the circuit exactly as you see the schematic. You build it how it fits the best. Now, so we got that. And I think I pretty much covered this. The LED drops about 2 volts. We set a voltage, which is about whatever voltage we set here. It's going to be about 0.6 volts higher right there. But that's in relationship to the positive supply. So I will grab the multimeter. Hopefully not banging too much stuff. The probes kind of dangle and get wedged and stuff. But yeah, we can take that voltage measurement there. So we have the 220 ohm resistor. Right now it says about 7 milliamps of current. Again, this is not as accurate as measuring the current with a multimeter. But we set it to voltage. This is an auto ranging meter. I can just set it to V and it does the rest. It was kind of pushing the camera back. And I don't have to move the red probe for anything but high current. And now we will take a look. So first we will take a look at the base voltage. So I don't know exactly what it is. Probably somewhere around 2.5. We're about halfway. Okay, 2.8 right there. And so it's not an exact 0.6 volts. Probably somewhere between 0.6 and 7. But 0.6 volts higher would be 2.443. But I bet it's a little higher than that. So I'm guessing, or 3.4 I mean. And so about a little bit higher than that, I think will be about 3.5 at the resistor right there. And okay, I must have did, we're a little bit lower than what I calculated. But in any case, there you can see, it's approximately 0.6 in that range, volts higher right over here. And so that's going to set the voltage across the resistor there, about 1.644 volts. And I can't do the mental math, but we have, somewhere around 7 milliamps of current. So I'm sure that adds up. So that is how this circuit works. You set the voltage across the resistor, and it's going to push current through the LED. And the LED does drop a couple volts, so we probably only have a maximum of 3 volts that we can work with. At some point, it doesn't matter how much more voltage I get. We're going to level off with that current. And yeah, I can kind of show that with the power supply right here. So again, this isn't an exciting circuit. There you can see we're about 2/3 of the way. We already got, about 11 milliamps current. Going up a little bit more, we got 12, but that's where we leveled up. It stopped going. That's because we can only get so much voltage across the 220 ohm resistor because the LED is dropping about 2 volts. So that comes up in a lot of circuits, and so hopefully you've already come up with that before. If not, you really need to study more simple circuits. But again, this is just the demonstration one, not a terribly exciting one or a useful one. Now, I promised we'll come to the ground and negative 5 volts instead of 5 and ground. So that applies here and there. If you're going to apply to one, you got to apply to the other for this particular circuit. So that's what that means. You can just do the standard 5 volts positive and ground, or else you could have ground and a negative 5 volts in relationship to that. So in the real world, you probably would not just see this. There would probably be positive circuitry on that side of ground. Maybe there's an NPN bipolar junction transistor doing the same thing that the PNP is doing down here, just they have opposite polarities. And so whatever this is doing, you could do with an NPN, but polarities are opposite, of course. Usually you learn the NPN, like the 2N3904. And if you want a PNP version, you got to design it all from scratch. So that's what I did here. Again, it works the same as an NPN would, but polarities are opposite. So now we're working with a more negative voltage, you know, going from ground to a more negative voltage instead of the normal positive going to ground. So in any case, that's about it on that. So this went on really long. Again, not probably something you'll really find a use for, although setting a current with the PNP bipolar junction transistor, I did right. It's a high side. That's the main thing. Whenever you look at PNP, like current source or switch, it is on the more positive side, whether that's ground or the positive voltage in relationship to ground or negative voltage. The switch, or current source in this case, is at the higher voltage than the load right there. So it's controlling the load from the high side. So it could be an output. I could wire this up where I make sure it's outputting like 1 milliamp of current, and whatever load we put will get 1 milliamp as long as we have enough supply voltage right there. So it's not the best way to make a current source if the supply voltage is going to change. But if the supply voltage is always a rock steady 5 volts, this is a good way to set the current with the resistor right there. So in any case, yeah, just kind of quickly made this video after work, and so I hope it was good enough for you. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you on the next video.